afternoon. Good afternoon. This is Suraj Singh speaking from Bharat, India. On this day of May 27, 2021 afternoon, because in morning time I could not relay my video through Facebook. I tried many times. Then I shifted to YouTube, and from there I could not do document share because that provision doesn't exist in YouTube. This is benefit of Facebook, that I can talk by face or I can talk through documents. I think it's dual benefit, but early morning for last 3-4 days I will finding that there has been big problem with Facebook. Whether they check it or they don't check, I don't know. Whether server remain down or no, I don't know. I don't get any signal. Early morning around 3:30 or 4 o'clock, I could not get that one. Facebook should look into this, why it's happening. I don't know reason for that. However, I am now moving up, and that is certifications I'm just displaying for your sake, because these certificates mean something. Certification are not for just paper. These are required for life. These tell something to public, that this person is competent, this person has certain capacity. That point we have to understand. And if we don't work according to our competency, then there is no meaning of calling oneself professional. What is professional? That certificates tell, but these certificates must be honored by certificate holder. If these certificates do not have any value, then what's the use of these certificates? Professional should work according to professional ethics, according to, you can say, technical way, according to required quality, demanded quality. Only quantity is not adequate in profession, because common people do not know, but they suffer due to bad material they get, bad product they get. So my topic is very clear. My topic is very, very clear, and it says that this talk is regarding civil field engineering, impact of COVID on profession, designs, construction methods, contracts, organizations, communication, coordination, quality, AnnexSL, and reasons of talking about quality. That's most important. I try to explain in varying ways every day, and I like it also that people should know different aspects of profession, different aspects of quantity and quality. Every item in our profession, it may be civil engineering, electrical engineering, mechanical engineering, or other branches of engineering whichever are involved directly or indirectly, all are having certain kinds of I can say requirements, certain items, hundreds of items, specifications, descriptions, limits, mathematical involvement they have. How much we comply in our work. If I talk of civil engineering, or I talk about mechanical engineering, or I talk electrical engineering, whatever we talk of, we have to be careful. We should be careful for production, for manufacturing, and for construction, in whatever field we are. I am in construction, which also imports work of electrical discipline, mechanical discipline, HVAC discipline, plumbing discipline, and many other disciplines, electronics discipline likewise. If my product doesn't fit in, or it doesn't serve for durability, it doesn't have durability, I mean to say, then what's meaning of product? Just put certain posters on your wall in office and tell that we comply with quality system. We have a policy for customer satisfaction. We are ISO 9001 certified, or we are Sigma certified, or we are this or that. These poses do not work. if our product does not give satisfaction. Customer or user, end user expects something out of money spent. Every customer desires that whatever value one has paid to buy something, buy some article, buy some product, that product should perform accordingly or according to description given by manufacturer, or is given in by that, I would say is description of catalog. Whatever catalog defines specifications of performance, that should deliver that. But unfortunately it doesn't happen. Machine which expected to serve you, it fails after some time of buying, while guarantee is extended to 2 years or 3 years. What does it mean? It means guarantee is a cover up, warranty is a cover up, right? So why cover up? Point is that why cover up? Just a minute, put on sit down. Are we leaving for cover up, or we are going to use product? I am not interested in warranty or guarantee. I am interested in performance of that material for whatever life it is given. It is supposed say for 5 years, for 10 years, it should work without problems. But it doesn't work sometimes even for a week. And sometimes you feel very upset. I purchased it last week and it's not working today. Then somebody will come, technician will come and say, oh, this is voltage fluctuation, or this is this and this is that. There are 10 excuses for one answer. 10 excuses for one problem. This happens because they will blame others. Means who is trapped? Customer is trapped. Customer is trapped, not manufacturer. Because manufacturer has already taken money. Manufacturer has got what he expected, including warranty cost. Warranty is never free. It includes cost of maintenance for warranty period. Price includes that. It's never free. Then after collapse of warranty, say 1 year or 2 years, you have to go for AMC, annual maintenance contract. So they charge again, and they keep on charging every year. This means that is expansion of business in terms of management. A kind of MBA product, you can say. You charge amount one time for price for purchase, including warranty costs, and then you go on charging post warranty, and you may call it by whatever name. This means this is business and this is not profession, or you may say profession of business. How to extract money from that customer who paid you once for product, then you have to pay that product cost. Original cost includes cost of maintenance or warranty, and then you have to pay for maintenance for 5 years, 10 years. So where is quality? My question is that. I understand quality required everywhere. It should be everywhere. Everywhere means in profession and also extra profession, I would say normal life. If I remain in tension in normal life that I bought this product is not working, I have to call, I have to write, or I have to send mail, then I have to wait for technician to come, attend him, like that. Means I have to take care of everything. And I have 10 products, for example. I have 10 equipment in my home or in office. So we have to follow up with everyone. Then where is quality? Is it quality that you have to be busy with maintenance work? We call it quality, or you have to perform? If I have to call every week someone, please come, this product is not working, and that person takes 4 hours, 5 hours, 1 day to come, and I do stop use of that product for that period. Means it is awesome. It's really awkward. I'm not getting quality. and you said products okay. It happened with me many times. New products went out of order just for after 1 week. Means what do you expect? High professional companies, high level professional companies like Microtech, like many others, you can say many others. It applies to all. The product goes out of service. I have to say then, I understand quality required everywhere in engineering, and it is a must. But question remains, is it? We have to answer this question. Who will answer this question? There is no one to answer this question. Nobody cares. Nobody cares. Means we should think of systems quality, or we should think of individuals quality, or we should have element quality, or product quality, or what should be our attitude for quality, what should be our dedication for quality, what should be our commitment after all, and what should be other parameters that should be considered. These points come to consideration as pool. We simply can blame the system is not working. We simply can, system has broken. What do you mean system has broken? Or it happened because of some spare part didn't work. Or there's some happen in out of 100 parts, one part didn't work. Well, you can answer, you can respond in whatever way. You have got money. You are not going to replace. You say, I will repair this. Because you know consumer is dependent on you. What to do? If I don't buy from you, I have to buy from someone else. And same thing happens there. Same instance happens here. Means, even if system works, product doesn't work. I think performance cannot be measured, can be understood only. How to measure performance? Because there are many restrictions possibly, many pros and cons. So we have to be very serious about quality issue. Now I say we deal with structures, we deal with other items, machines, appliances. We have to use all. As user, what I think, and as engineer, what I think, and as in charge, what I think. These are all different issues. When I talk of structures, of every you can say item, every machine, every building, or wherever the structure is concerned, I have to talk of quality. Previously we used to think quality is meant only for materials, only for workmanship. No, quality applies everywhere. Quality applies in process, it applies in manufacturing, it applies in construction, it applies in procurement, and it applies in delivery of material, delivery of service. Everywhere quality lies, and that's the only reason when somebody serves you from some company under AMC or otherwise, then they immediately call, please define our services on this URL. You fill up this form and tell us how it was, what time was there, time-wise, punctuality-wise, that guy came or did not, he understood problem or not, or he explained to you what he should do, or what was his grade of service. They immediately ask for that. Just for 1 hour service or half an hour, so they raise you 10 questions. Please post on our website, put link to Facebook, like that they do. Means 1 hour service, half hour service, you raise so many questions. When this machine was manufactured or this structure was constructed, you might have taken months. For machine there have been many weeks. If you can ask so many questions for just half an hour service or 1 hour service, how many questions customer has to ask for months of services you have to do? For example, you constructed some building, it must have taken 1 year, 2 years. You have a right to ask questions, right? If we can't ask questions, this means we are not faithful to ourselves. Means we trust This means if I don't ask questions, even before booking of some structure, some house, some apartment or some other, I have a duty, I have a right to ask questions because I am making payment. But how many of people, how many of ourselves ask these questions? They say, okay, I got booking, it's enough, I got booking, at least means for millions of rupees you paid and you said I got booking, and I am upset even for 10,000 rupees product. So what I am saying is people are also ignorant because there is no question from public. So why should contractor, why should engineer, and why should all those stakeholders in construction and procurement worry about? I am blaming myself also. I am an engineer and there are thousands of engineers. They are not worried about quality, not at all, I am sure. They say, yes, we will work according to quality, but saying is not enough. It should be seen working. They do not think of this very seriously because people do not think very seriously. If suppose all people buyers start raising questions, give me this, show me this, show me this, show me this report, show me that report, show me this, explain to me this and that, show me your design procedures, show me your construction procedures, I want to see what you did. They would say, manufacturer, so there's third party, there's third party, we have got to cost. No, I don't believe in a third party. I want to see myself. This is my engineer representative and this person will investigate you. That doesn't happen. That doesn't happen. So there is no fear. There is no concern. Nobody is concerned. Nobody is concerned. I've seen writings by many engineers, hundreds of engineers and thousands of engineers on various websites. There are so many websites, civil engineers websites, structural engineers websites. I don't find any noting, any question, any view. They write about designs, they write about this and that, which public don't understand. They never talk of how design shall be implemented, what problems may come. They should write. They are documenters. They are doctors of engineering. Means it doesn't mean they have PhD. It doesn't mean. Those who have experienced for whole life, they are more than doctors, but no voice. They are only busy in their codes, they are busy in only procedures of designs, they are busy in research of designs. They never care for product. And I think that is where they don't show responsibility, total responsibility to a profession of structural engineering. Just designing is not structural engineering. It's a part of structural engineering. You may design RCC, you may design structural steel, you may design pre-stressed concrete, you may design whatever you want. It's only a part of structural engineering. Production, implementation, delivery of structure is more important than design. If you take it that way, if that structure which has been designed very well and it is done very badly, now what's the meaning of the design? If design doesn't equate to construction, what's meaning of that? No meaning of that. And really I am speaking in high pitch because it's not happening. The structure is not being delivered according to design meeting, according to requirement meeting, according to specification meeting, and person who pays, that person actually gets substandard work. In fact, there is no awareness of design, there is no awareness of quality, there is no pro-initiation, there is no pro-action, you can say. There is no pro-action. This means we stand nowhere. All stages designs, all stages design must be concerned. We have to be concerned about all stages of designs. If design doesn't satisfy or suffice, doesn't satisfy customer because it doesn't suffice. If construction and developments are not affected to mark, design drawings must have quality which they don't have. They must be coordinated properly, but they are not coordinated properly. These are IFC drawings, you can say issue for construction. You cannot issue drawing for construction until it is coordinated well. Well, you can say exemptions are there, but when you say it's IFC drawing or AFC drawing, which are approved for construction or issued for construction, this must be duly coordinated, having all details which are required for construction and also required for site working conditions. These structural engineers must take into consideration this point. They have no right to say only this was left and that was left. You have a duty to deliver drawings which are competent and consistent. You cannot deliver incomplete drawings, and you cannot say they should demand later on. They will demand or don't demand, that's different. You can't issue incomplete drawings. It's your duty to check it. You cannot say that person, other one check and the other one check. It's not question of checking. It's not question of, you can say, endorsement. It's not question of proof checking. It is question of detailing. Drawings must be completely detailed, or you may call it must be like, it must have a status of working drawing, not simple drawing. Drawing looking at which people start working, it should be that status. It should be speaking drawing. I cannot say every drawing is like that, but I just suggest what I feel there may be some lacuna. Construction based on reasonable coordinated quality designs is a must. All activities must be taken care of, but you know what happens. Now, what should be way to achieve that? It's duty of site man also, site person also, to coordinate drawings. I'm not saying exclusive responsibility goes to designer. Designer has design part of responsibility. Design part, when you issue structural drawings, it must be duly coordinated in all respects. But there is another coordination which is to be undertaken by site representative, site agent, or you may call site organizer, leader. Drawings which are used for construction activities must also be duly coordinated. Coordinated means coordination of architectural and structural detailing, coordination of structural, architectural and services detailing. Everything must be organized properly, must be studied properly, and if somebody finds certain conflict, questions should be raised for correction of that conflict, for resolution of that. That resolution can be done by design engineer, or that can be done by some other method. That depends on question, that depends on conflicting details. Coordination in designs and coordinations in construction are very important methods, are very important disciplines or sub-disciplines, because you have a pool of drawing on sites. I am talking of big sites, prime sites or building sites, where you will find drawings from all disciplines, and those drawings are not one or two, many, and you have to go through them. Electrical engineer shall work on electrical schematic drawings for purpose of producing working drawings or shop drawings. Similarly, air conditioning engineer or mechanical engineer will work on HVAC drawings in relation to structural drawings. And also, plumbing engineer shall look out into his discipline, plumbing discipline, through structural engineer's drawing or some other drawings. It depends on various disciplines. Structure and services are very important for purpose of construction on site, because the structure has been designed in relation to architectural design. So architectural work shall come later on, because first structure is to be constructed. So structural drawings and first structural and architectural drawings must be considered together, even if designer has considered them, because there could be any site customization, there could be something else also, and we have to make sure that whatever architectural drawing says, whatever architectural drawing requires, structural drawing responses to that. Because implementation on site or prosecution on site is to be done in terms of structural items, not in architectural items. Architectural item work shall come later on once structure is over. Structure starts our site. It may be foundations, it may be excavation, it may be foundation items, it can be superstructure or upper floors, whatever you say. Structure should be understood properly, and if there is error in coordination between architectural and structural detailing, that is first step that every person involved on site must look after. And if there is some disparity seen or observed, that must be taken care of and question be raised, or whatever procedure we have for resolution of that question, that problem should be done at an earliest, so that there is no impediment left to come in way of construction. Construction can't be delayed, that is also true, because that is a question of contract data. No one has right to delay construction, because it impacts on contractors, it impacts on owner, it impacts on schedule, and it can impact on cost as well. So we have to keep in mind these things. And when service engineers have to work on their drawings, their respective disciplines, for plumbing work, for sanitary work, for electrical work, for HVAC work, for lift work, or some other work, or whatever is required there, gas supply, all that, or if any special item is there for furnishing or something else, that covers scope of work, then all those items, all those must be studied properly, and those involved drawings must be given to vendor. All relevant drawings must be given to electrical, mechanical, plumbing, or whosoever is there, a specialized field engineer. Those drawings requirements must be given to them, so that they know what are sizes of beams and columns, what is other structural requirement, and what height of these beams are, what sizes of these columns are, what height of floor is, what height of false ceiling is located at, and their ducting work should comfortably pass through spaces, or you can say planar. And same way, there must be adequate space for trunking for electrical cables, and all cables to pass, and wherever you see lights are to be placed in ceiling or whatever means, it should be completely defined. Suspending ceiling system should be completely defined. You can say reflected ceiling fans must be done. So these specialist engineers must have sufficient information, and of course they do have specifications, so they have to produce shop drawings and working drawings within defined period, so that work can start. When you do construction activities for RCC, wherever these inserts of services have to come, particularly electrical inserts, as well as blockouts for HVAC or mechanical or plumbing or sanitary or else, this information should be ready. If you don't have this information, even if you start work shall stop. And this should be part of what we say methodology of work. Construction method statement is a requirement here, which must include all this. All details must be expressed in a convenient format for performance and for defining elaborate object of performance. Elaborate details must be there. This is very important, means if you don't have these drawings, this is you can say interference in work stops. So what I am saying is about this method statement that I'm talking of. You know what is method statement. There are very method statements, specific method statements on which site a project, and these are different one. All disciplines method statements are required, and all shop drawings and working drawings are required. All coordinated drawings are required. It's not only shop drawing and working drawing, coordinated drawings are also required. You may say, what is this? What is shop drawing? What's working drawing? Yes, shop drawing or fabrication drawing, working drawing, site execution drawing, and coordinated drawing, which discovers, and which you can say, if you do coordination drawings, for example, there are many services running in external work. Many services running in some complicated areas, so you have to draw services and then see there's no clash here, and these services have compatibility with each other, electromechanical compatibility or some other compatibility, and there should be no you can say this is the piping around, something around, these should not clash, there should be enough space to accommodate that. So that's called coordination drawing. Coordination drawing means where all services are shown and specification models are followed up, codes are followed up, and then there should be no clash. These services should pass comfortably in their vicinity, vertically as well as horizontally, with complete accommodation, and that's coordination drawing. Means it depends on your project, it depends on requirement. There sometimes you can see many clashes, and those clashes should be avoided. So construction method is not alone. It's not simple writing, you can say. Method is not writing alone. Method is a mix-up of various activities of construction, designs, or you can say semi-designs. You may say there are so many involvements in method statements. That's what sometimes we call them methodology. Science of working on site, and not science in laboratory. Means it's the system that you have to form to work specifically per requirements on site. It may have some drawings with it, or you have to make drawings from shop drawings or from working drawings, or you actually have to extract information and put on that, or you have to define method for such particular item, and that can be included as attachment to method statement. Means there's no generality on method statements. Yes, there are some statements like reputational activities. You may say this, for example, excavation is no generalized one. There is different excavation everywhere. Shuttering can be, you can say, can be formwork, can be generalized. Steel cutting and fixing can be generalized. Tiling work can be generalized. Means there are some methods, some items which can be generalized, but there are many items, and sometimes many more that cannot be generalized. So we have to keep that point in our consideration, that it doesn't happen. So construction method depends on intelligence and the smart attitude of those people who run projects. These are design work related, and we have to take into consideration all this approach. Now I will come back to this file after going through some other file, and that file is that here last time I was doing on quality requirement. On quality requirement file, I was working on that, and actually I tried to share it today, but I could not due to whatever reason. In this there are many statements I have put in. There are only 44 pages, but there are some very specific statements. Or not statements, actually I can't say, I'm sorry, it's not a statement, it's just checklist, or you can certain points to be kept in view. I'm just giving a title. This is checklist and ITPs, though these are not ITPs actually. These are just support to checklist and support to ITP. What we have to consider in specific activity is it's a miscellaneous type of statement to provide information to those engineers who have to work in field. Means what does checklist means, and how you can convert this checklist to ITP. Checklist means items to be checked for work that has been done or to be done on sites or on projects, and then how to take these items into form of inspection and test plans. If I'm just here talking about checklist, means what expectations you have, what items you have in mind or depending on site that you should consider important from checking viewpoint stages, or you say you must keep in mind. There can be no guide to such practical activity on every site. There is no formula. This is not bending moment shear force. There is no Chinese theorem. This is not that. This is individually oriented. It depends on every activity on site. There may be many types of details on sites, and check may be different, may be varying. We have to keep in mind this is not general work. This work relates to a specific requirement, and that is very, very important. Who is this? Malla English Bachta Ye Nahi Pana. What is the Lahore survey? Lahore survey. What is this here? Marathi. What is this? Who is this? Mr. Lahore survey. Lahore survey. What do you want to write, my dear friend? I can't understand what you are writing. Malla English Bachta Ye Nahi Pana. Can you explain in simple English? It will be better. Maybe you are from Maratha. I don't know what is this. Means Maharashtra. I don't know. People write. I think what is this? I don't know this. Well, let me continue. Some people may write anything. So in this case, I started with setting out an excavation. I talked at length of that one. Then I jumped on to. I will come back to this item later on for further explanation. I am just giving you these titles. Then it was about hand excavation, and also this was about, you can say, formation below foundation, formation, or you can say foundation level. Then it was about blinding item, blinding. After that it was concrete protection, and waterproofing, both are same. After that it was foundation or footings preparatory works. It is then stub columns, preparatory works, stub, STUB, stub columns. For my consideration, stub column in this point, at this point in this checklist, is that column which starts from foundation, footing, and goes to plinth level. From there, exposed column starts. This stub column remains embedded in soil. To my experience, some people may have different experience, I know, and they define it differently, but here is what I can say. My thought and my experience based what? There is a definition in one page. A stub column is a column whose length is sufficiently small to prevent failure as a column, but long enough to contain same residual stress pattern that exists in column itself. And also there is what is difference between a stub and a column. Stub is a non-structural pier. Well, that is something else. Column is an RCC structural member. Stub is pier. Not this is not pier. It's not that. Stub column or floating column or linked column, we know column stands on footing, but when coming to stub column, it won't have any footing. This is planted column they are talking. Reinforced detail of column stands on slab or beam, shear, support. I think people are a little confused. Yes, what are planted columns? This is planting column, floating column. A stub column is a column whose length is sufficiently small to prevent failure as a column, but long enough to have this stub definition. A short piece remaining after something has been cut. Okay, so there are different definitions for all this. So I just try to see what people think about that. But work says that we call it starter column. You can say. So we can say I have explained my meaning of stub column, so there should be no confusion. That's what I think about stub column, and we have used this term. You use this term on our projects. So stub columns, and then we have go back to backfill works. Backfill, which is very important item. I can say it's very important item. Then backfill is also having some more. I just let me see if I can get some information of backfill from. I didn't backfill. You can say backfill information, backfill designs. I can say backfill designs. Backfill design. I say this is mine backfill. I'm not talking mine backfill. What it says backfill designs. I'm talking of something very important item. How can you design backfill? I read somewhere in the document that's a different case. And let me see if I can get some very good information on that. It's maybe probably. Let us see what is that. It's going on opening. Oh my god. Assessment of backfill design for cable TV repository. Easter Johnson Leavitt says this, introduction. Let us say what it says. Introduction. Anything is there. Let us say something. In initial stages of repository conceptual design, backfill design for deposition tunnels was based on a mixture of bentonite and ballast compacted situ in deposition tunnel. In process of developing a robust basis for repository design and barriers performance, it was determined in a number of laboratory studies. That's performance of backfill material, especially swelling pressure and hydraulic properties, depend not only on density but also on salinity of percolating water, a factor that has not been completely factored into initial design concepts. In addition, based on field tests performed at ASPO, now says it's very much, I think, technical, but we have to. I see if I can find some basic of design. Let us say basic design presented in this section was selected at the end of this, and degree of block filling in basic design developed by Becklow. Okay, I think it's not doing something. Okay, we'll take it later on. I think this is not giving proper information. I thought. Leave it. Okay, backfill material. This section will examine backfill materials considered. Backfill material considered in backflow phase. This specifically objectives of this section can be broken down to two main categories. Firstly, to present what is known on mineralogy and chemistry of material that were chosen for further studies in backflow. This information is important in order to interpret results from tests described in following sections, self-sealing tests. And secondly, the section will present some of key geotechnical parameters for materials studied in order to determine what density these materials are able to fulfill requirements section backfill. Okay, this is material studied. Okay, leave it for using this. I think I'm getting all information. To continue on my talk. I thought something comes in. Okay, fine. Backfill works. To my experience, they have certain backfill items. Again, I explain. We can use backfill material which was excavated from that area, provided its source. It's suitable. But if it does not, can't backfill with that, we have to import material from other sources. And there are so many granular materials available in nature, or we can get from them. Gradation is very important. You can say granular material is very important, suitable. Clay is not suitable, and there's a design of that, or the desert fill, you can say. In sand, you can say there are so many items that can be mixed together for backfill purpose, so that we can get good grading as well as we get good field dry density. And we can also call that sometimes engineered backfill, structured backfill, engineered backfill, structured backfill, normal backfill, or you can say desert fill. Your purpose is that there should be adhesion to material, there should be densification, and we should not depend on consolidation for whole. We should have such materials which interlock together and densified. Or you can say granular size, grading, good fineness modulus, or you should have complete grading, means from highest size of, you can say 75 mm down to size of sand, so that no voids without material are left, very few voids. And of course there should be enough permeability in that, so that water doesn't stay in that all time. So field dry density indicates whatever material we go to fill, it should have certain density. But what is that density? From where does it come? People sometimes do not understand that. That material which we are going to fill as backfill is first tested in laboratory for its suitability, and if it is found suitable, or it is suggested that you add something else into that material by so many %, so that expected curve is obtained by that mix, and we get theoretical or experimental percentage of that, and we compare when we do in field this dry density we achieve in field to whatever extent, 98%, 95%, or whatever, we compare it with this tested Proctor density. So there are fills particularly for structural items, surrounding structures, or below structures if it is required. Below structures if we depend on fill, though it should not be, but in some cases it's called soil improvement. In some cases where we say we have to fill with structural material so that that load is transferred to that. If that is the case, that is called engineered fill. Engineered fill, it is used for purpose of transmission of direct load and other loads to soil below. This engineered fill is very much important for heavy foundations. For example, LNG tank, or heavy raft, or heavy machine foundation, where natural soil is not suitable for work, or it may be landfill area or lake, you can say reclaimed area. There are many situations, artificial situations or natural situations, where underlying soil does not fit in, and it's no use compacting that because of structural requirement, future requirement. So we have to form certain layer below that structure. There can be one layer and there can be many layers. I have seen fills up to 3 meters below LNG tanks in Doha, you can say in Doha Ras Laffan. I saw engineered fill to an extent of 3 meters or 2 meters, I don't exactly remember, and every layer was tested. It is a very beautiful use, grading, granular fill, no clay, no silt, and they formed tanks, big tanks, big tanks, because 80 meter diameter tank, containment, with height 50 meters. Such, you can say, such voluminous tanks of metallic containment and metallic tank with RCC containment, pre-stressed concrete containment, and that fill was engineered upon. It is for big industrial projects. It's industrial projects, oil project, and there are so many. It can be done also for high-rise buildings, raft foundations. Means sometimes you have different type of soils or clay soils, or we have even soft rocks which don't work to that requirement. So engineered fill is done or a structured fill is done, and there's benefit that in that case you don't worry for consolidation. Consolidation worry is diminished. Means, in fact, you say in that fill and compaction, consolidation works immediately rather than to be followed after compaction. Immediate, you can say, consolidation happens. You may require settlement, of course. Settlement you have to be sure about, but consolidation, it applies only to soft soils, applies to, you can say, like clay or silt. You have to think that it will consolidate itself in 50 years or 60 years. In granular fill, in engineered fill, in structural fill, that situation doesn't happen. So we have to understand, beauty, you can say, beauty of this requirement. That's why I say backfill can be designed. Okay, I talked of heavy structures, industrial structures. There can be light structures also, for example, residential building or commercial building or offices building. They are not necessary that you have to do that high technological fill. You can just improve soil normally. You must have your soil investigation report, borehole logs reports, plate bearing test reports, electrical resistivity, you can say conductivity, thermal resistivity, thermal conductivity, and many more such tests, and many more such recommendations from testing laboratories you must have. You are an engineer, you understand soil, we understand technology. Okay, we might not understand material at that time, but when we get report, we can understand, we can construct meaning of that, we can interpret that, and that's what is required. Means we should not be blank. Practical aspect we must have. We salute design, but design should also salute reality. And that reality is, lot of work is done in such cases, in such works which are neither design related nor work site related. These are in between, where research, where thoughts, where application of investigation or soil investigation is ascertained on site. Sometimes it is given, it is included within the specifications or on drawings, that you have to make sure minimum safe bearing capacity on site during excavation when you reach your formation level. We require minimum bearing capacity this much on site, and this must be tested. It can be more, but minimum it should be that. Because of certain reasons, this is indicated on drawings, not indicated, you can say it's mandated. It's mandated on drawings, and we have to do that. This means when you excavate and reach certain level, and you say my formation is almost finished, what I have to do? What you have to do? Read specifications, read design requirements, and there is a requirement to call laboratory come with truck and test, plate load test, conduct that one, so that you know what is bearing capacity of that one, that area. If it's one test, you do one test. If two tests, you do one. Means you have to make sure that your design meets requirement. So that's the reason I try to explain this item, though it's very small item, it's very small explanation, but this is very important item because your structure is going to cite on that. It is the original item, you can say original, important, significant item that starts your work. So I can read it again if required, means because this is very important one, and this is checklist for backfill work. Though I have read it many times, but just for refreshing, you can go ahead, no problem. It says make sure that selected fill or imported fill or desert fill materials are approved, and make sure that recommended additive materials are made available if so required. Make sure that stocks of backfill materials are located in some reachable place, and make sure that different fill materials have been procured and mixed in defined proportion in case backfill material has been designed to meet fill requirement to achieve required grading of FTD. Required grading FTD is field dry density. Make sure that screening of large particles well done, and make sure that proper watering on material is effected for initial mixing. Check whether or not all substructural activities are completed, including block or brickwork. Check that all rubbishes and debris are cleared from area. Ensure concrete protection membrane applied on all surfaces and well protected. Ensure bottom portion of shoring removed. Ensure stages of shoring removal during backfill progression. Ensure backfill activity approvals prior to start backfill layers. Ensure necessary equipment available, shovel, small roller, plate, compactor, etc. Decide number of backfill layers of defined compacted thickness 150 mm. Decide number of field density tests required from every layer. Decide number of passes of small roller or plate compactor. Decide to use jumper at corners where compactors otherwise cannot reach. In some cases, reverse sand could be used when compaction causes certain problems. Whatever material we use for backfill must conform to required grading. These are very normal. You can extend this checklist depending on your material your work. Then it was checklist for grade slab at plinth level. We also call that flat floating slab. It's not structural member, it's just a slab for ground floor level. This is not connected to beams. Yes, it is connected to beams when there is basement, otherwise not. If this is basement, there's basement below, then this grade slab becomes structural slab. And then like grade slab, this may be back in your basement. Well, now this is ordinary work. We'll go further, Then we discussed about RCC column works. After that, we studied about checklist for RCC wall works, and then we studied about RCC lift well wall works. This is also very important item. I read it full last time because this is very standardized item and very much abnormal in our country. Then RCC stairs, I will read this for your refreshing memory, particularly this RCC lift, because it's an important item for doing. It's not easy, not at all it is easy. Thank you. Good afternoon, Mr. A.K. Topo. Thank you very nice for joining, and I hope you enjoy. Now I'm just going to tell you checklist for RCC lift walls for item number 12, and I like to show you sketch also for this. I show you last time also. List is where is the sketch execution plan. I'll go to sketch and show. Is very important to show. so that you get clear idea. This is technical work and one should get clear idea. That's the only reason that I'm going to reach that file. Just a minute, please let me show you that file. It's better. General record, and this is my folder, and here is management documents. I have method statements, that's chapters, and this is sketches. Okay, then sketches. What's that sketch? Oh no, method sketch, not sketches. Yes, it is here. I think somewhere here it should be, and it should be. I will show you both sketches. Water reservoir. Wall form and lift form. I will show you both. I will show you both for your reference. Lift form and wall form. Both are important. So I will show both so that you are clear. It is now, and also another one. I'll just show to you, explain to you, and put back. First you see, this is that. This is for wall, RCC wall. You can see this is wall. Let us say it is 4 meters high and whatever thickness. It is doubly reinforced, so thickness shall be certainly more than 20 centimeter, 30 centimeter. It is no problem. There are some shear walls, you can say. There may be some other walls, fascia walls. 30 means it is a shear wall and structural wall, you can say. And it is 4 meter high, so it's considerable. And when it's 4 meter high, means we have to cast 4 meter height one time. No stage casting. 4 meters means 4 meters. Here you can say 20 mm thick. Tie bolt, which is half to 1 meter center, and here is strain reinforcement inside, and then various locations where supports would come in. And you can see this is plan. Okay, this continuation of that. This is 1 meter spacing here. Okay, let's see now. This is general it's a standard type design or diagram or sketch for certain RCC wall formwork, and this is site fabricated. It can also be, you can say, hired from some proprietary manufacturer who manufactures forms. It's up to you. If you can do yourself, do yourself. Let us say now what here in this. Of course there is ply, and that is supported, that's fixed backing by timber at defined spacing, or you can say fabricated plates of plywood and timber are erected and various connections are given. That is normal. The important point is what? The important point is we have to provide tie bolts, yes, that are here in this. This can be erected directly, no problem, and these locations can be made sure, no problem. Plumbing. Important is this: when you fill in concrete is fluid, it's liquid, it stays there as liquid for a couple of hours, and that liquid transmits horizontal pressure, or you can say resultant pressure according to fluid mechanics. This is height, air pressure, density. In water we considered 1. In concrete we shall consider 2.5 tons per meter cube. So 2.5 into 4 here, 2.